important that you understand how to do it. And the reason why is because it's going to come up in the next 3 chapters. The big topic for today is called factoring. Now, you're going to have to know how to factor different types of problems. There's a total of 5 different types of problems you have to know how to factor. The first one that I did for the warm-up was to talk about the greatest common factor. So it says define each of the words below. Use your own words or Google it if you don't know. So I'm just going to give you a quick summary of what I think these 3 words means. Greatest to me means the biggest. Common means they all have it or do it. And then factors are numbers that multiply to give us a specific result. Cool. So when I talk about factors, I'm telling you, tell me 2 numbers that multiply to give me a certain answer that we're looking for. So what I've done below is I Googled it. I Googled what factors were. And this was the example that it gave me. Now, I pulled up this example on purpose because when it comes to a greatest common factor, you're going to find that there's a lot of factors. Things have a lot of factors in common, but there is ultimately only one greatest common factor. And that's the downfall a lot of times. If you don't find the biggest number possible that they all have, well, then you're going to get it wrong, because technically that's just a common factor, not a greatest common factor. So in this example right here, the GCF is 4. And you can see, like, they both have 2s, and they both have 1s. So if you don't put down the 4 as your greatest common factor, that affects everything else we do. So it's going to be super important that you make sure you pull out the biggest number possible. Now, once we find that greatest common factor, usually what we do is we divide it out and we write it in the front. So you can kind of see right here at the top, this is what it usually looks like when we're done. Whatever that GCF is, we put it out in the front, and then we write what's left after dividing out the GCF. Now, the thing that's tricky about GCFs is that GCFs could be numbers, they could be letters, or they could be both. And if you don't pull it out right, it affects all the work that we do after it. So you just need to check for it. And I'll also, I'll show you, how to check for it and all that stuff. So don't panic just yet. Okay. So, first one. Let's take a look at this one right here. I'm going to first teach you how to tell if you can take out letters. You can take out letters if they all have the same letter. So you can see that one right there. The 9, it doesn't have a Y on it. So that means we can't take out any letters. So the next thing we look at is just the numbers. I see a 3, a 6, and a 9. And the thing that's weird is it's called the greatest common factor, but we're actually going to start with the smallest one. We're going to start with the 3. Can the 3 go into 6 evenly? Can the 3 go into 9 evenly? If it can go into all the other stuff, then that's called the GCF. So that means that what we could do is we could just divide all terms by 3, and then your GCF goes out in the front. Now, after you take out that GCF, the result goes on the inside. So we're just left with y squared minus 2y plus 3. Now, sometimes you will have to watch, because sometimes the stuff inside the parentheses will factor more. We call that multi-step factoring, and you're actually going to see that a lot today. But I'm going to tell you right now that this one doesn't. And I'll tell you some of the patterns that happen later, and how you can tell if it does or if it doesn't. So that's basically the answer. When we say factor, we mean take out a GCF. That should be the first step of every single problem that we do. Always check to see if there's a GCF. Okay, so let's take a look at the next one. It says factor 8y squared minus 12y. So let's start with the letters. Can we take out any letters? How can you tell? They both have it, right? If they all have the letter, that means you can take out letters. Now, again, it's called the greatest common factor, but it actually works backwards. We're going to take out the one that has the lowest exponent. So we're going to take out a y from both of them. Now, we're also going to check the number, though. So we've got an 8 and we've got a 12. So I want to start with the 8. If you have a GCF, it's never going to be higher than the lowest number. So it's either going to be 8 or something lower. So does 8 go into 12 evenly? Nope. So I go down. 7 doesn't go into 8, so I don't have to worry about that. 6 doesn't go into 8. 5 doesn't go into 8. 4 goes into 8. Does 4 go into 12? Okay, so then it's going to be a 4 also. Did you notice how I started high and worked my way down? That's because of this example up at the top. This guy right here. We want to work from the highest to the lowest because if you go the other way, you're going to get something that works right away, and that might not be the greatest common factor. So we want to try to start from the lower of the two numbers, start with that exact number, and then work your way down from there. So to write the final answer, we just put 4y in the front, and then we put the result to that division problem in the parentheses. So if this has 2 terms, inside the parentheses should have 2 terms. So this gives me 2y minus 3. And that's our answer. So what I'd like you guys to do is I'd like you to give it a try now. There's a couple of practice problems. I'm going to give you about, 2 to 3 minutes to find the GCF of each one. If you guys will kind of look up in the front, I wrote some stuff down that should be kind of happening in our head. And if you can't do this in your head, then write it down. The strategy that I talked about is we start with, so I see the 12 and I see the 64, so we're going to start with 12. We always start with the smaller one. In the calculator, I do 64 divided by 12, and it doesn't work. So then, using this list of factors for the 12 didn't work, so then I just work my way down the list. So I do 64 divided by 6. I don't think that works either. Then I do 64 divided by 4, and it does work. Well, it's definitely going to work in 12 because it's a factor. If you have a factor of a number, then that means it'll divide it. So that means that our GCF is going to be 4. Now I have a question for you guys. Can you take out any letters? No, that was a trick question. I said earlier that if they all had letters, that you could take out letters, but I should have said if they all have the same letter. These have 2 different letters in them, so we can't actually take out any letters. So that means that our final answer here is going to say 3x squared minus 16y to the 4th on the inside. And I don't know if you guys realize this, but all we're doing is the distributive property backwards. The distributive property takes the stuff from the front and multiplies it into the parentheses. All we're trying to do is take it out and put it back in front. But there's a couple of rules that you have to follow. It has to be the biggest and the most number of letters possible. So that's your answer for the first one. In the second one, does the second, yeah, it definitely has a GCF. I can already tell. Starting with letters, I see that all 3 of them have X's in them. So that means that I can pull out 1 X. And the reason why it's just a single X is because the lowest one is X to the first. If I was to try to take out X squared, I can't take out 2 X's from the 9X. It's impossible. It only has 1 X. As far as the numbers, you got 3, 27, and 9. We always start with the lowest of the 3. So 3 goes into 27, 3 goes into 9. So that means 3 works. So we're going to put 3 out in the front also. Then we put the results on the inside. So we end up with x squared plus 9x plus 3. And then that's your final answer. So far, this is how we do GCF stuff. You want to make it a habit of trying to find a GCF because later on it's going to turn problems a little bit easier. In fact, if you guys will turn to the next page, I'm going to give you guys some rules. We're actually going to move on to a different type of factoring, but I want to give you some rules on the next page. So each quadratic that we have here is written in standard form. Standard form just means you have the highest exponent first, then it goes down, and then you have the constant at the end. But there's also this pattern to where, let's say the exponent is x squared, the middle one is always going to be half of that. So that's x to the first. If I had x to the 10th in the front, the middle one is going to be x to the 5th. It always just has that pattern. Now, I'm going to teach you how to factor, but we're actually going to do this backwards, and we're going to talk about some patterns that occur. I already gave you the answers. These are the answers. This is what those problems would look like in factored form. These, by the way, are called trinomials, but they're also referred to as simple ABCs. You're going to have to know that for the test. Your first few questions of the test, I'm going to give you 5 different problems, and you got to tell me what type it is. So these ones are called simple ABC. Why is it called an ABC? It's because the general form is like this: ax squared plus bx plus c. So we call that a simple ABC. And the thing that makes them simple is that the number in front is always 1. So that's what makes it a simple ABC. So I'm going to give you guys a couple of rules here so that we can investigate this pattern a little further. Let's take a look at these numbers on the inside. So just look at the 6 and the 2, including the signs. I want you to do 2 things for me. I want you to add the 2 numbers, and then I want you to multiply the 2 numbers. You know what we'll do is we'll extend the table, and we'll put all of our answers in here. I'm going to give you about 30 seconds to add the 2 numbers and then multiply the 2 numbers. I'll give you an example if you're confused. Inside of here, I have a 6 and a 2. They're both positive. So when I add them, the answer is 8. When I multiply them, the answer is 12. So fill out the rest of that table. Add the 2 numbers. Be sure to use the signs that are in there too. So as you guys are doing this, you really need to be aware of your signs. Like, we don't usually write this, but that's a positive 8 and that's a positive 12. If I was to take these 2 numbers in here and add them together, -4 plus -3 is -7. -4 times -3 is positive 12. If I take the 2 numbers inside, +3 and -5, if I combine them, it's -2. And then if I multiply them, it's -15. If I take the inside 2 numbers and I add them, +6 -4, that's +2. And then if I take +6 and -4 and multiply them, that's -24. Now, do you guys notice a pattern though? We just did 2 things with those 2 numbers that are in our parentheses, and I'm not sure if everyone noticed this, but they kind of match up with these right here. That is exactly how you get the numbers in here. So our strategy is actually going to be kind of to work backwards. So I'm going to teach you what that strategy is here on these simple ABCs. So number 1, you always have to check if there's a GCF. So that's the first thing you're going to write down. It's in red because it's not always possible, but you should always check. So always start by trying to take out a GCF. So if you look at that first one, does the first one have a GCF? I don't think it does because I'm looking at the letters and it doesn't have Y's in all of them. What's the smallest number out of the 3 numbers? Smallest number is 1. If I divide out a 1, it's not going to change anything. So we just don't do it. So here's what we do next. These letters are always set up in ABC order. We're actually going to start off with the letter C. We're going to make a list of all of the factors for the 3rd number, or the last number. So I'm going to take this 8, and I'm going to just write it off to the side. And I want to list all of the pairs of factors that multiply to give me 8. So I'm going to start with 1. So it's 1 times 8, and then it's 2 times 4. And if you notice on the left side, all I'm doing is going up. I'm just counting. 1, 2, 3 doesn't work. 4 works, but 4 is already up there. So when they start repeating, that's how you know you have your whole list. So that's the entire list that can multiply to give us 8. But here's the catch. We now have to put some signs on and try to make it combine to the middle. So don't forget, the way these are always set up, A is in the front, B is in the middle, and C is at the end. So we want to pick the pair of numbers that's going to give us the number that's in the middle. So out of these two sets of pairs, this is the only one that could possibly get us to 6. If I add 1 and 8, that's 9. If I subtract 1 and 8, that's 7. So it doesn't get us to 6. The last thing we have to make sure is that the signs match. So we have to make sure that it multiplies to the last number and adds to the middle. So everything is positive here. If your problem is full of positives, they're both positive. Now it's just a matter of writing the final answer. So here's what you do to write the final answer. Whatever your first term is, I don't care what letter they use, whatever that exponent is, cut it in half. So in ours, it's y squared. So what we're going to do is we're going to put 2 sets of parentheses. If I cut y squared in half, it's y. So I put a y here and a y there. And then the work that we did off to the side, those are the 2 answers that go inside. So I put plus 2 and plus 4. That's our answer. Now you could check if you got this right by foiling it out. If you foil it out, it should give you the original problem back. But we don't want to do that. I already know it's right. If you had a test and you still had 20 minutes to kill, you can always check these answers and make sure you got them right. So let's see that again. I'm going to show that to you again in example 2. So in example 2, this is a simple ABC. I don't care that it's an 8 and a 4 in the exponent. It follows the pattern. If the first one is 8, the next one is always half of it. It's always going to work like that if it's a simple ABC. Not only that, there's the 1 in front. That's especially what makes it a simple ABC. So in a simple ABC, we start with this last number right here. So we make a list. Let's start with 1. So it's 1 and 24. 2 works, it's 2 and 12. 3 works, it's 3 and 8. 4 works, it's 4 and 6. 5 doesn't work. 6 works, but it's already there. Now, out of that list, is there any pair of numbers that could get us to 11? That's going to be 3 and 8. Now, after I pick that pair of numbers, now I have to put the signs on to make everything work right. How do I put signs on 3 and 11 to make it add to negative 11? You would make them both negative. Perfect. So this is negative 3 and negative 8. So if you check this, they add to negative 11, and they also multiply to positive 24. Now it's just a matter of writing the answer correctly. So if my A in the front says 8, all I do is cut it in half. So I put 4 here and 4 here. Then we take those 2 numbers that we circle and put those signs on. We put 1 in here, and we put the other one over here, and that's our answer. Okay, now if you guys take a look at example 3. Example 3, it's not exactly ready to go yet. Because if you follow what I was saying earlier, if the first one has 3, the second one should have half of that. But we don't have exponents like 1.5. We don't use those here. But what you should notice is that all of them have an x. So that means that it has a GCF. So the first thing we want to do is take out the GCF. That has x3, x2, and x, so I take out the x. And now I need to rewrite this problem with 1 less x. So this now becomes x squared minus 1x minus 12. Now this follows the pattern for a simple ABC. It's simple because there's a 1 in front of the x squared, and it's an ABC because the first term is an x squared, and the middle one is half of it. It's just x. So now we can follow the same things that we did before. So I always start with the last number. We're going to find all the stuff that multiplies first. So I start with the 12. I use 1 and 12, 2 and 6, 3 and 4. Out of that list, I have to find one pair that's going to combine to -1. Or just one. I don't even care about the sign right now. Let's just find something that gives us a 1 if we add it or subtract it. Which pair of numbers would that be? It's got to be the 3 and the 4. Then we go back and just make sure we get the signs right. How would we put signs on this so that when we add them, it gives us a -1? We would put +3 and -4. See, and now that you got those signs on there, when you multiply them, it gives you the -12 at the end. So this parentheses splits up into 2, and then if that's an x squared, I just put an x here and an x here. We put the two numbers that we had in the circle right here. We put 1 here and 1 here. And guys, it doesn't matter which one you put first. If you want, you can put -4 first and +3 second. You'll get the same answer. Just don't forget about the x in the front. The GCF has to be a part of your final answer because you should be able to multiply and get back to that original problem. So if you forget this x, you're not going to get back to x to the third if you FOIL it all out. And that's our answer. So the big idea for today, there's 2 of them. You have to find the GCF, if it even has one. It could be a number or it could be a letter. If you find one, it goes in the front. Then we talked about the simple ABC. What makes something simple, like when it's an ABC problem? What are we looking for? What does it have to make it simple? It's a 1. The front number is always going to be a 1. If that 1 changes to something else, we have to do it a different way, using a different method. And so I'll teach you that another day. But for right now, that's what I wanted you to learn. When you have your simple ABC, you use the last number to make the list, find 2 numbers to get you to the middle, and then put the signs on so it matches the middle, and then that will eventually make it so that it multiplies to the last number also. So once you have your numbers in your list and you circle it and put the signs on, that goes into your 2 parentheses and you're done. So that's pretty much it, guys. There are more examples in your notes, but that's where we're going to get into. We're going to get into the Big Ideas website that we signed up for last week, and you guys are going to finish off those examples using the Big Ideas